Hey guys, we are on 12.4, so this is the first day of volume, which is really nice because it's much easier than surface area. So notice these are the formulas we're going to use today, much shorter than surface area, which is nice. So the capital B is still the area of the base, that hasn't changed. The height is still the height, it's perpendicular with the base. So remember, we're not using slant height like we did last section. We're using the actual height. Okay, let's go ahead and look down here on prisms. So our formula is volume equals the area of the base times the height. And the area of our base is going to be the area of this triangle down here. So I'm going to color in our bases. The height is still how far apart are the bases. Okay, so our capital B, we're going to have base times height divided by 2 because we are only looking at this triangle down here. So capital B is 3 times 1.5 divided by 2, which is 2.25. Okay, so now we have our capital B, we have our H, which is this. How far apart are the bases? So we have everything we need. 2.25 times 5. So the volume is going to be 11.25 centimeters. Alright, and now this is volume, so it's centimeters cubed, because this is how many cubic centimeters can fill up this shape. Alright? Much easier, right? So number 2, volume equals area of the base times the height. This is actually a really nice question because you don't have to use trig and solve for the apothem and find the perimeter because it already gives us the area of the base. Will this always give us that? No. Just for the notes purposes, it does. So for this one, the area of our base is 10 and our height is 4. So the volume is 40 inches cubed. So that one was really easy. Just remember that you won't always be given the area of the base. At times you'll have to use trig or use special right triangles to be able to solve for the area of that. Alright, moving on to the next page. Now we are looking at cylinders. So for cylinders, it's still the same formula, volume equals area of the base times height, but our area of the base is a little different. So it looks like this, pi r squared times h. So you can solve for the area of the base separately, or you can just do this and plug in those two numbers and be good to go. Let's zoom this in a little bit. Okay. So the volume equals pi times the radius squared. It gives us the radius, 2.5 squared, times our height. So it's how far apart are the bases. The bases are the circles here. So 7 is what it gives us. So 43.75 pi. That's if you're just multiplying the numbers. So 2.5 squared times 7. But we are going to go ahead and plug this in. So put this in the calculator. 43.75 pi in the calculator. It's 137.45 inches cubed. Okay. So moving on. Now, pretty much the same thing. I know it looks weird, but this gives us the height. So if there's ever a time, if you are not given this piece, say you're given this piece and this piece, you can always use Pythagorean theorem to solve for that 11. But this is the correct side because it's perpendicular with the base. Okay? So we're good to go. It's at a right angle with that circle. It's at a right angle with that circle. So we can go ahead and put our formula in. Height. Pi times the radius squared times the height. So pi times 2 squared times 11. So our volume will be 44 pi, or 138.23 centimeters cubed. Alright, pretty straightforward. Now we're going to work backwards. I know we've done some of these in our homework where we are solving for just one of the sides. Okay, what's really nice about this, so this is volume of the base, volume equals the area of the base times the height. What's really nice about this is anytime you have a prism, it's also, it could be, or a rectangular prism, length times width times height. I'm sure that's how you have seen it before, because length times width is the same as the area of the base, so that times that. So really you're just multiplying these three numbers together, but you're already given the volume. So we can plug 661.5 in for the volume, and then 3.5 times 18 times y, because we can use that length times width times height formula. So now you have everything except this y. So what you want to do is you want to take 661.5 and divide it by those two. So we could times 18, multiply those together, 3.5 times 18, 661.5, and then divide it by that 63. So we get 10.5 centimeters. Remember, this is not cubed because all this is that side length there. Okay. So really the key to this is just plugging in everything you know and then solving for the variable that you don't know. Okay. Same idea, except we're using the other formula. Volume equals pi r squared h. So what do we not have? We don't have the r. So we can plug in our volume. Oops. Volume is 75.36 times pi times the radius squared, which we don't know, times the height, which is 6, because that's how far apart the circles are. So, what you can do is divide by 6 pi on both sides. So just put this in the calculator, 75.36 divided by 6 pi, and you get like 3.99. So I'm just going to write 4 equals the radius squared, because when we take the square root of that out, we get a pretty number. So 2 inches is what our radius would be. Alright, so I'm going to show y'all these down here. It's asking to describe how the change affects the volume. So if you multiply the radius by 5. Okay, so let's find the radius of this one, or not the radius, the volume. So pi r squared h. You can plug these numbers in. Pi times the radius squared, which is 4, times 6, so 24 pi. Okay, that is when the radius is 2. Say we multiply it by 5, and it becomes pi times 5 times 2 is 10. 10 squared. The height will stay the same. Okay, so it becomes a much larger number. So the volume equals 600 pi. Okay, so now we found our 2 volumes, but it's asking what is the change. So what do you have to multiply this by to get to this? So all you have to do is divide 600 pi divided by 24 pi, and then you get 25. So what we just found is that we're multiplying this by 25. We're just multiplying this by 25 to solve for this. So the change was when you multiply the radius by 5, you're actually multiplying the volume by 5 squared. which is 25. So that's what it's trying to get you to figure out. All right, and then if you can kind of see the pattern that we have going on here, when you multiply the length and the width by 1/6, okay, so the original volume would be 3 times 12 times 18. So 3 times 12 times 18 is 648. So that's the original volume. Let's figure out what happens when we multiply the length by 1/6, which is the same as just dividing it by 1/6. So we're going to divide the 18 by 6. We're going to divide the 12 by 6. So it becomes 3 times 2 times 3. So this 3 comes from right here, 18 divided by 6. This 2 comes from right here, 12 divided by 6. And the 3 stays the same, because that is the height between the two bases on the top and bottom. So 3 times 2 times 3 is 18. And we just need to figure out what is the change, 648 divided by 18. So the change between those is 36. So when you multiply the length by 1/6, the change in the volume would be 1/36. Alright. And that's just kind of what it wants you to figure out. So you find the two volumes, and then you divide them, and you figure out what you need to do to this first one to get the second one, which multiplying it times 1/36. Alright, that's all for the notes today. So thanks for listening.